Hello and welcome to today's class. Let's solve yet several past questions in the study of aromaticity. So last class we dealt with the introduction to aromaticity, and we said there are three classes of aromaticity. We have the aromatic compound, the non-aromatic compound, and the anti-aromatic compound. We said conditions for aromatic compound is that number one, it must be cyclic. Number two, all carbon atom must be conjugated. Number three, it must contain 4n plus 2 pi electron, and finally it must be flat, like, or must be planar. You want to, so that's like the condition for aromatic compound. Also, we have the what we call the anti-aromatic compound. For anti-aromatic compound, how do we identify them? Number one, it must be cyclic. Number two, all carbon atom must be conjugated. Number three, it must contain 4n pi electron, and finally it must be planar, or we want to must be flat. And lastly, we have what we call the anti-aromatic. For anti-aromatic, the condition there is that number one, it must not be cyclic. Number two, all carbon atom must not be conjugated. Number three, it can contain even or odd number pi electron, and finally, okay, we said for planar or non planar, we don't have that does not exist in anti-aromatic. So what I just mentioned are the conditions to spot out either a compound is aromatic or anti-aromatic or non-aromatics. So we have dealt with the conditions in our previous videos. I'll drop the link to our two classes on in the concept of aromaticity in the description of this video. So I'll drop a link there where you can learn from scratch. So let's look at this compound here and give it naming. It says that identify each of the following species as aromatic, non-aromatic, and anti-aromatic, please. So how do you get this done, please? We said first things first, let's have number one, please. Number one, please. We said conditions for something to be aromatic, non-aromatic, or anti-aromatic. Let's get it up, please. First rule is that it must be cyclic. This compound here is cyclic compound. True or false? Of course, true. Rule 2, all carbon atom must be conjugated. In this case here, all carbon atoms are not conjugated. By the word conjugated, I mean that for every edges, we should have a double bond carbon atom. Of course, here is double bond, carbon, carbon, carbon. Of course, these 4 carbon atoms, 1, 2, 3, 4, are attached to double bond, double bond, double bond, double bond. This one here is not attached to a double bond, right? So this one now, it's not a condition for aromatic compound, aromatic, and also anti-aromatic. For the two, for aromatic and anti-aromatic, we said all carbon atom must be conjugated. In this case here, it is not conjugated, of course, because what there this becomes from a non-aromatic compound, please. Becomes a non-aromatic compound. We said for non-aromatic compound, all carbon atom must not be conjugated. We said that earlier. Next up, we have this compound here. Let's give this compound naming. Is it aromatic, anti-aromatic, or non-aromatic? Of course, we said rule 1, it must be cyclic. True or false? Of course, this one is cyclic. Rule 2, all carbon atom must be conjugated. In this case here, all carbon atom are not conjugated, please. This because what they're a non-aromatic compound. Next up, I have this one here. All right, CH3 here is called an alkyl group called methyl. CH3 is called methyl. So I have 2 methyl here attached to this compound here. First, let's name this compound. Is this compound an aromatic, non-aromatic, or anti-aromatic? Please don't check out for substituents. Methyl, so CH3 here are called substituents. You don't check out substituents. We only look at these 4 conditions, please. Number 1, it must be cyclic. This man is cyclic, please. Condition met. Number 2, all carbon atoms must be conjugated. Look up, please. At this point here, conjugated. 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 At this point, conjugated. At this point too, conjugated. So all carbon atoms must be conjugated. True or false? Of course, true. Rule 3 says it must contain 4n plus 2 per electron. That's for aromatic, or 4n, that's for anti-aromatic. Please, let's first here, let's count the number of pi bond here. We said for every double bond there's 1 pi bond. So here I have 1 pi bond, 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 and 1 pi bond. How many pi bond in general? 1, 2, 3, 4, 5, 6. For 6 pi electron, is it aromatic or non-aromatic? For 6 pi electron, we said we have 0, 2, 4, 6, 8, 10, 12, right? So we said this is what this is for anti-aromatic. This is what aromatic. This is what anti-aromatic. This is what aromatic. This is what anti-aromatic. This aromatic. This anti. That's how it works, please. So I'll not stress myself bringing out 4n plus 2 4n. Just check here. This 0 is anti-aromatic. Aromatic is just an even number concept, please. In this case here, look up, please. So if I have 1, 2, 3, 4, 5, 6, if I have a 6 pi electron, for 6 pi electron there, this is what? An aromatic. Of course, this compound is what? An aromatic compound. Why? Because it's fitting all the conditions for aromatic, please. Finally, please, let's get this man done. Is this man an aromatic compound, anti-aromatic, or non-aromatic, please? First is first, it must be cyclic. This condition is correct, please. Rule 2, all carbon atoms must be conjugated. In this case here, let's confirm, please. Conjugated, 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 and also conjugated. This is about 4 questions. All carbon atoms here are conjugated. Rule 3 says 4n plus 2, or perhaps 4n. That's for 4n plus 2 is for aromatic compound. 4n is for anti-aromatic. So look up, please. Let's get total number of pi electron first. For every carbon attached to double bond, a pi electron exists. So I'm saying that for every carbon atom double bond, there's only 1 pi electron there. So I have 1 pi electron, 2, 3, 4, 5, 6, 7, 8. Please, for 8 pi electron, is it aromatic or anti-aromatic? For 8 is what? An anti-aromatic. So the compound is called an anti-aromatic compound. So this is how you distribute aromatic, non-aromatic, and anti-aromatic in a given compound, as you can see. So do well to watch our previous classes in the concept of aromaticity. That will give you a better understanding of what I'm doing here, right? So do well to watch the previous classes so you can be familiar with this little concept. All right, see you in the next class, and welcome to Excellence Link Academy. Do well to visit my website at www.ganiyu.com. My website, you get a full tutorial video on organic chemistry from scratch. So a full tutorial video, and once you purchase the video, it's a lifetime access, right? You get a lifetime access to the full course to organic chemistry. Alright, see you next class and welcome to Excellence Link Academy.